Hi all, let's continue with question number 26. Question number 26 says, a vehicle travels half the distance with speed v and the remaining distance with speed 2v. Its average speed is. We know when distance is given, half of the distance travels with one velocity s by 2 with a velocity v1 or speed v1, remaining half of the distance with another speed v2. Average velocity equation or average speed equation we have 2v1 v2 divided by v1 plus v2. So it is a straight substitution. You're given v1 as v, v2 as 2v. Then what will be the average speed? Average speed is going to be 2 into v into 2v, right? v1 is v, v2 is 2v divided by v plus 2v. That is your final answer. So we get 4v square divided by 3v. V gets cancelled. We get 4 by 3v as our answer. Option 2. So it's a direct substitution question, right? We have the equation for average speed for half of the distance with one speed, remaining half with another speed, 2v1 v2 divided by v1 plus v2. We substituted, simplified, we got the final answer. Okay, question number 27. The half-life of a radioactive substance is 20 minutes. In how much time the activity of the substance drops to 1/16th of its initial value? We know the activity relation R by R0 is equal to 1 by 2 whole raised to n. We have the same equation for number of particles also, right? N by n0 is equal to 1 by 2 whole raised to n, where that n stands for number of half-lives, right? Number of half-lives. And number of half-lives can be calculated as given time divided by half-life, t by t half. Yes, so you are given number of, initial activity is R0. Now, at present, we have 1/16th of initial activity. So, R is given as 1/16th of R0. So, if I substitute that, I will get R0 divided by 16R0 or 1 by 16th is going to be 1 by 2 whole raised to n. Right? So 1 by 16 is equal to 1 by 2 whole raised to n. So this can be written as 1 by 2 whole raised to 4 is equal to 1 by 2 raised to n, so that we identified number of half-life required is 4. Number of half-life required for reducing the activity into 1/16th of its initial value is 4 half-lives. You are given half-life as 20 minutes. So what will be the time required? Time required is equal to 4 into t half, right? From this equation we can find number of half-life is t by t half. So t is equal to 4 times t half, which is 4 into 20, and that is 80 minutes. Yes, which is option 3. Question number 27, option 3 is the answer. Here also, it's a direct substitution we have. Our activity ratio, R by R0 is equal to 1 by 2 raised to n. Question number 28. Temperature of a gas is minus 50 degrees Celsius. To what temperature the gas should be heated so that the RMS speed is increased by 3 times? Okay, see, 1 or 2 points you have to remember here. One, RMS speed of yes, so the RMS speed equation, that is root of 3RT divided by M or 3 kBT by M. In both the cases, we can say V is directly proportional to T, temperature. And that temperature should be absolute temperature. That is one of the very important points you have to remember when we deal with this equation. Right? Temperature is, SI unit is absolute temperature, that is to be substituted here. And you are given the temperature, the initial temperature, T1 as minus 50 degrees Celsius. So we have to convert that into Kelvin. Yes, so T1 is going to be minus 50 degrees Celsius, minus 50 plus 273. We get 223 Kelvin. That is your K. That is your T1, first temperature. You are asked to find out what is the new temperature so that the RMS speed is increased by 3 times. Be careful. It is not increased to 3 times. It increases by 3 times. So if the velocity, RMS velocity increases, or RMS speed increases by 3 times, at present it is V, it is added by 3V, therefore V2 should be 4 times V or V1, right? We have taken V here. So if it is V1, we can say V1 plus 3V1, that is 4V1 will be the final velocity. RMS velocity increases by 3 times. Okay, so that is what happens here. Now, from this relation, we can say V1 by V2 is equal to root of T1 by T2. Correct? Yes. So V1 is V1 only, but V2 is 4V1. Root of T1, initial temperature we calculated, that is 223 Kelvin, right? 223 Kelvin, and that divided by temperature T2. Yes. If you square on either side, we see V1 and this also 4V1, right? V1 gets cancelled. If you square on either side, we get 1 by 16 on LHS, 223 divided by T2, and therefore T2, the new temperature at which RMS speed increases by 3 times, is going to be 16 times 223, which is 3568. So temperature, the new temperature should be 3568 Kelvin. Check the options. We don't have Kelvin options corresponding to this. So convert that into degrees Celsius. When you convert this into degrees Celsius, T2 minus 273, that will be 3295 degrees Celsius. See, Kelvin converted to degrees Celsius because there is no matching option for Kelvin here. So this is the first time. The first option is the correct answer. Okay, so 2 points I told you. 1, remember to convert temperature into absolute temperature. And the second thing, regarding the change in RMS speed, it is not changes to 3 times, it changes by 3 times. Okay, so the final value will be 4 times its initial value. That was the next important point. Okay, question number 28, option 1 is the correct answer. Now, 29. Question number 29 is about a Carnot's engine, coming from thermal physics part, like thermodynamics. Efficiency is given as 50%. When its source is at a temperature 327 degrees Celsius, temperature of the sink is. We know the equation for efficiency of a Carnot engine, eta is equal to 1 minus T2 divided by T1, right? Where T2 is the temperature of the sink, the lower temperature body, right? And T1 is the temperature of the source. Always T1 greater than T2, right? Source is at the high temperature, T2, sink is at low temperature. So eta, efficiency is 1 minus T2 by T1. And you're given efficiency in percentage here. Therefore, eta value is going to be 0.5. 50% efficient means eta, it will be 0.5. Yes, here also we have to take the temperature in Kelvin, absolute temperature. So 327 degrees Celsius is given. That is the temperature of the source. T2 is given. The T1 is given, right? So your T1 value is 327 degrees Celsius, which is going to be 327 plus 273, that is 600 Kelvin. So T1 is ready for substitution. We have to find T2. Easy. Now direct substitution only. If you transform this equation, we can say T2 by T1 is equal to 1 minus eta. 1 minus eta is 1 minus 0.5, which is 0.5 only. Then what can be T2? T2, the required answer, T2, temperature of the sink, is equal to 0.5 into T1. T1 is the temperature of the source, which we already found out, or is given in the question. 600 into 0.5, that is going to be 300 Kelvin. We can search for the options now. 300 Kelvin is the temperature. That should be the temperature of the sink. 300 Kelvin is not given. All answers are in degrees Celsius. So this is nothing but 27 degrees Celsius, right? Yes. So which option? Option 4 is the correct answer. Okay. This is the very important point. Whenever we deal with questions from thermal physics, temperature, we always take temperature in absolute temperature, Kelvin scale. Okay, fine. Question number 30. The magnetic energy stored in an inductor of inductance 4 microhenry carrying a current 2 ampere is. Right. So here you are asked to find magnetic energy. Again, a question from, moving charges part, like, magnetism part. Energy U is equal to half L I square is the equation. Energy stored in the inductor, that is stored in the magnetic field, right? We know. Yes. So energy stored in an inductor is half L I square. You are given all the values. You have to just find out what is the energy. Just substitute and simplify. We get half into inductance is given 4 microhenry. So 4 into 10 raised to minus 6 into I square. Current is given as 2 ampere. So it becomes 2 square becomes 4. Yes. So we get this gets cancelled by 2 and we have to go for 8 into 10 raised to minus 6 joules, and which is 8 microjoule. Be careful. 8 microjoule and 8 millijoule also given. 8 microjoule is the correct answer. Direct substitution. U equals to half Li square. Correct? Time saving questions. Fine. So question number 30 is option 3 is the correct answer. Now question number 31. Let a wire be suspended from the ceiling from a rigid support and stretched by a weight W attached at its free end. The longitudinal stress at any point of cross-sectional area, of the wire. See, again, a straight, simple question. When you suspend a wire freely from a rigid support, and we suspend a weight at its end. See, W is a weight suspended. We know in equilibrium that weight will be balanced by the tensional force in the string. There will be a stretching force, right? Yes, that tensional force will be equal to what? The weight suspended in equilibrium. Yes, and we know how to calculate stress, longitudinal stress. Longitudinal stress is a normal stress, right? Acting normal to the cross-sectional area of the wire. Longitudinal stress. Yes. So across the cross-sectional area of the wire, stress is going to be that force divided by area of cross-section. In the question, it is given that A is the area of cross-section of the wire. And what is the weight we suspended? What is the force acting? Force is the weight suspended divided by cross-sectional area, right? So the stress is going to be W by A. Question number 1. See, option number 1. How simple the question is. Directly a conceptual one, right? A simple concept. Fine. Question number 31. Option A is the correct answer. Okay. Now, 32. An electric dipole is placed at an angle 30 degree with an electric field of intensity 2 into 10 raised to 5 Newton per Coulomb. It experiences a torque of 4 Newton meter. Yes, torque is given 4 Newton meter. Calculate magnitude of the charge if dipole length is 2 centimeter. Yes, see, straight substitution. If you know the expression for torque acting on a dipole in a uniform field, we can solve this question instantly. Torque is equal to, what was the expression for torque? P E sine theta. Look at this, all values given except P, and that P is going to be what? 2A into Q, right? This is the P value into E sine theta. That is the remaining term. Torque is also given. You are asked to calculate what is the charge and all other values are given. See, quite simple. What is the torque value? Torque value is 4 Newton meter. Yes. Now, length of dipole. 2A stands for total length of the dipole. And that is given in the question as 2 centimeters. So 2 into 10 raised to minus 2 meters. That is the 2A value. We'll substitute that. 2 into 10 raised to minus 2 into Q is to be calculated into what is E? Electric field strength in the region. 2 into 10 raised to 5 Newton per Coulomb. So 2 into 10 raised to 5 into, and you are given the angle as 30 directly in the question. See, dipole moment makes an angle 30 degree with the electric field direction. So it is sine 30. Sine 30 is going to be 1 by 2. So now simplify this. Sine 30, fine. So this 2 and 4 gets cancelled by 2 here. So 2 is equal to, Q is to be calculated, 2 into, yes, this 2 and sine 30 gets cancelled. That's also gone, right? So now we can say Q into 10 raised to minus 2 into 10 raised to 5. So we get Q into 10 raised to 3, that is equal to 2. Therefore, what is your Q? The charge, magnitude of the charge of dipole, that is going to be 2 divided by 10 raised to 3 Coulomb, which is 2 into 10 raised to minus 3 Coulomb, that is millicoulomb. 2 millicoulomb, which is option 3. Correct? 2 millicoulomb. See, direct substitution. Torque is equal to PE sin theta. If you know that equation, solved. And also one more thing, dipole moment is 2A into Q. Finished. So question number 32, option 3 is the correct answer. Right. Now, 33, question number 33. In hydrogen spectrum, the shortest wavelength in Balmer series. See, Balmer series. The second series, right? First one is Lyman. Balmer series is lambda. The shortest wavelength in bracket series. Bracket series is the last but one series, like 4. Last one is fund, right? P fund, and then before that is bracket. So Balmer series and bracket series comparison. And in both the series, we are going to check, or we are going to take the ratio of their shortest wavelength as per the question. See, shortest wavelength is always obtained when it comes from infinity to the initial orbit, right? So for Balmer series, we can say, for Balmer series, initial orbit is equal to 2 and final orbit is equal to infinity for shortest wavelength, right? Lambda minimum. We know lambda minimum is for maximum frequency, maximum energy. Maximum energy transition is when the electron comes from infinity to the initial orbit. Yes. So NF is equal to infinity. For Balmer series, shortest wavelength. Now, if you go for bracket series, shortest wavelength, again, initial orbit will be different. It is 4th like series, right? Ni is equal to 4 and NF is still infinity only, because shortest wavelength is transition is always when electron comes from infinity to the initial orbit. Yes. So for Balmer series is this, and bracket series. What about bracket series? For bracket series, we can say Ni is equal to 4 and NF is equal to infinity, because we are going for minimum lambda. Yes. Now we have Rydberg formula. We can just directly substitute for that. Rydberg formula 1 by lambda is equal to, right? For Lyman series, for Balmer series, we are going for minimum. So it is going to be R into 1 by Ni is going to be 2. So it becomes 1 by 4 minus, see, because our equation is 1 by Ni square minus 1 by NF square. Correct? So for Balmer series, what will be the equation? What will be the value? 1 by lambda is equal to R into 1 by 4 minus 1 by infinity is going to be 0. So we get 1 by lambda is equal to R by 4 or lambda is equal to 4 by R. So question says that wavelength is lambda only, right? Wavelength, minimum wavelength of Balmer series is given as lambda, which is 4 by R. Now we try the same thing for bracket series, then we'll take the ratio. For bracket series, minimum wavelength 1 by lambda dash is equal to R into, what is the initial orbit? It is 4. 1 by Ni square becomes 1 by 16 minus 1 by infinity, again 0, right? So we have 1 by lambda dash is equal to R by 16, or lambda dash is equal to 16 divided by 16 divided by R. Yes. See, we have lambda and lambda dash. Now, when we take the ratio, we get the new lambda dash is equal to, 4 lambda, option 1, right? Yes. So, lambda by lambda dash is equal to 4 by R divided by 16 by R. See, you will get lambda dash is equal to what? 4 lambda, option 1. So, Rydberg formula, right? Brackets, Balmer series and bracket series. Series number 2 and 4, minimum wavelength, that is maximum energy, highest frequency transition. Option 1. Question number 33, option 1 is the correct answer. Okay, now 34. The ratio of frequencies of fundamental harmonic produced by an open pipe to that of closed pipe having the same length is. We know the expression for fundamental frequency, right? Waves, chapter waves, 15, the last chapter from 11th class, right? 11th grade. And here fundamental frequency of open pipe is V by 12, where V is the velocity of that wave in that pipe, L is the length of the pipe. Yes, V open, right? Frequency of open pipe, nu naught is equal to V by 2L. And if it is a closed pipe, when we go for a closed pipe, it is V by 4L. We know this ratio. You're asked to find the ratio of these two equations. See? You're asked to find open pipe to the closed pipe. So new open by new close is going to be V by 2L divided by V by 4L. That is going to be 2:1, which is option number 1. See, direct question again. So if you know the expression for fundamental frequencies of, like first harmonic, fundamental frequency of stationary waves produced in a open pipe and closed pipe. Yes. Question number 34, option 1. And 35th question. Two bodies of mass m and 9m are placed at a distance r. Capital R is a distance. Right. The gravitational potential on the line joining the bodies where the gravitational field equal to 0 will be given 4 options. See, you are asked to calculate what is the gravitational potential. At a particular point, what will be gravitational potential is to be calculated in this question. And you are not given specifically which point is, or like you are not given this point, this much centimeter away from the first mass, this much centimeter away from the second mass, no specification given. That point, the importance of that point, the speciality of that point, at that point gravitational field equals to 0. Gravitational field is equal to 0. So you have to calculate potential at a point on the line joining the two masses where gravitational field is 0. We have to calculate potential at that point where gravitational field is 0. Okay, so let's see. We have two masses. This is my mass m and the other one is 9m. This is the 9m mass. And it is given that in the question the distance between the two is capital R. Capital R. So at a point on this line joining the two, gravitational field strength is going to be 0. There will be two gravitational fields, right? And like correspondingly, they'll be in the opposite direction. Whenever they are equal and opposite, what happens? The gravitational field cancels each other, right? So let us assume, see, it won't be at the midpoint because masses are not equal. And it is going to be the closer to the smaller charge. Let us take the distance from the small m to that particular point where gravitational field is 0 is small r. Okay. Then the remaining distance is capital R minus small r because the total distance was capital R. We identified a point or we assumed a point where total gravitational field is 0. We know expression for gravitational field, right? Gravitational field can be calculated. Field strength can be calculated as Gm by r square, right? Gm by r square. We use the letter E also there. Gm by r square. See, so there will be two fields. One produced by this small m. The other one is produced by small 9m, right? No, 9m mass, and the distances are r and r minus r. So if total field at the point O is 0, at the point O, field due to m is equal to field due to 9m. Field due to m is equal to field due to 9m. Due to 9m, right? Yes, using the equation we can say G into m, mass of the body is m, the first mass, divided by distance r square, right? Because to the point O distance was r only, so we will take r square is equal to the second mass 9m, G into 9m divided by what is the distance? R minus r the whole square, right? R minus r the whole square. See, we equated the field at that particular point. If they are equal only, they cancel each other. So that's why we equated. Correct? So we can cancel that G and m from either side. We get 1 by r square here and 9 divided by r minus r the whole square. Okay? Look at this. All of them are perfect squares. I'll take the square root from this on either side. 1 by r is equal to 3 divided by r minus r. Yes, we cross multiply now. R minus small r is equal to 3r or 4 small r is equal to capital R, small r is going to be r by 4. Yes, we located the point. Where will be the gravitational field going to be 0? At a distance r by 4, 1/4 of the total distance. From which mass? That is very important. From the small mass. Because we have taken the small r as the distance from the m. Right? No, m and 9m are two masses. Distance from m is taken as r. Okay, so we located the point. That is not the final answer, right? We have to calculate what is the total potential at that point. See, now total potential at O. Total gravitational potential at O is to be calculated. We know the expression for potential, gravitational potential, V equals to minus Gm by R, correct? So total potential is going to be V1 plus V2. How many potentials will be there at the point? 2 potentials. One due to the 9m mass and the other one is due to the m mass. So we will take the potential expression. The first one, V1, we are going for the small m first, or the m mass first, minus Gm divided by R, right? R by 4. And look at this. Now we will use only the capital R value. This is found to be R by 4 already, right? And the remaining distance supposed to be then 3R by 4. Yes. So first one, V1 is minus Gm by R by 4. And what about the second one? Plus minus G into 9m, right? The second mass is 9m. 9m divided by, what is the distance from 9m to the point O? 3R by 4. Yes, 3R by 4. Simplifying this, you will get one of the correct options. And we get, look at this, minus 4Gm by R on simplifying first term. And minus, here 4 comes up, 4 into 9, 36 Gm divided by 3R, correct? 3R, and 3 and 36 can be cancelled by 12. 12 and 4 becomes 16. So we get minus 16 Gm divided by R, and I think, yeah, we have an option 2, right? Second option is the correct answer, minus 16 Gm by R. Was little lengthy comparing to the previous questions, right? We got enough number of questions to save our time, and this was a little lengthy. We had to find out R first, then we have to find out the total potential. Okay, so question number 35, option 2 is the correct answer. Okay, moving on to the next. 36. A bullet from a gun is fired on a rectangular wooden block with velocity u. When the bullet travels 24 cm through the block along its length horizontally, velocity of the bullet becomes u by 3. Yes. Then it further penetrates into the block in the same direction before coming to rest exactly at the other end of the block. Total length of the block is. A question from one-dimensional motion, right? Basic question, very simple question. See, we have to understand the question properly first. We have a wooden block of some distance, right? Some length, some thickness, and a bullet enters this wooden block from one side, right? It enters from one side and it moves 24 centimeters horizontally along this direction of motion of the bullet. And if its velocity, initial velocity was u, at this point, velocity of the bullet is found to be u by 3. U by 3. Okay, so retardation happens. It's expected because when the bullet passes through the wooden block, there will be some retardation frictional force. Because of that, the velocity decreases. And at this point, velocity reduces to 1/3 of its initial value. Then it continues its motion. The rest of the information, like the remaining information is given, like it comes to rest exactly at the other end of the block. Exactly at the other end of the block. We don't know what is this distance. Let me take it as S or something. So after traveling some more distance, it comes to rest, and that point was exactly on the other side of the block. So the question is, what is the total length of the block, right? What is this total length of the block? That's the question. We can say something right now that L is 24 centimeter plus S, right? L is going to be what? L is equal to 24 centimeters plus, yes, we don't know what is that S. We have to find out that S. That is the final answer, right? Yes. Then look at this. We can calculate deceleration of this bullet, right? From the given information, if you consider the motion from A to B, then later from B to C. For the motion from A to B, what can we find? A to B, initial velocity was u, right? Initial velocity is u. Final velocity is u by 3. U by 3. At the point B, it has 1/3 of its initial velocity. What is the displacement by the time? 24 centimeters, okay, not meters, centimeters. That is what the question says. Total length distance traveled is 24 centimeter. Can you find out the retardation during this motion? And it is a uniform retardation throughout the motion. The block exerts the same retardation till the body or the bullet comes to rest. So we can find out that retardation from here. We can say from the equation v square is equal to u square plus 2as. This is the equation we can use. So here v square, what is v square? U square by 9, right? Because final velocity was u by 3. U square by 9 is equal to initial velocity is u square only. Yes, u was the initial velocity. That is how it reduces to 1/3 u by 3. Then plus, actually minus, because retardation, 2 into, we don't know the acceleration, but we know 24 centimeters is the distance traveled, displacement produced. We consider only the motion from A to B, okay, not the total motion, A to B. Yes. Now, what will be the result? 2 into 24 is going to be 48A, right? Is equal to u square minus u square by 9. So we can simplify this further. What will you get? 48A is equal to 9u square minus u square is going to be 8u square by 9. So A is equal to 8u square by 48 into 9. 8 and 48 can be cancelled by 6. 6 into 9 becomes 54. So we can say u square by 54 centimeter per second square. We found out acceleration. We got acceleration. So this is the retardation exerted by the block on the bullet. Yes. How this value help us to find out the remaining distance? I told you the remaining distance S is to be calculated to find out the total length of the block. See how that value A helps. Now you can consider for motion from B to C only. Just the rest of the motion, B to C. What is the initial velocity at the point B? It is u by 3. What is the final velocity at C? 0. Bullet comes to rest. What is the displacement to be calculated? And what is acceleration? U square by 54. So we have all the values. We will go for again v square is equal to u square plus 2as. Correct? This is minus, okay? Retardation. Correct. So that we have to consider here. Fine. So we have v square is 0. Final velocity is 0. Initial velocity is square of u by 3. We get u square by 9. Yes. Plus 2as becomes minus because it's a retardation. Minus 2 into acceleration is u square by 54 into s. Now only s is unknown. If you know s, you will get the final answer. Done. Finished. Right? So we will get u square by 9 on one side is equal to 2u square s by 54 on the other side. See, now easily you can simplify. U square gets cancelled. 9 and 54 cancels by 6. And we take that 6 to the LHS is equal to 2s. Therefore, what is s? 6 by 2, that is going to be 3 centimeters. Remember, we didn't convert any of the length. We kept it in centimeter. So, the rest of the distance is only 3 centimeters. Now, the question is, what is the total length of the block? Which is 24 centimeters plus 3 centimeter. And we got the final answer as 27 centimeters. Option 4. Okay. Question number 36. Option 4 is the final answer. 24 plus 3. That is 27. Yes. Fine. 37. Next question. The radius of innermost orbit of hydrogen atom is 5.3 into 10 raised to minus 11 meters. What is the radius of third allowed orbit of hydrogen atom? See, again, another time-saving question, right? Instantly we can solve this. We know question from modern physics, right? From the atoms, Bohr atom model, we know radius of Bohr atom, in atom model, Bohr radius R is equal to R0 n square, where this R0 was 0.53 angstrom, or that value is given in meters here, 5.3 into 10 raised to minus 11 meters. Check the options. Options are all given in angstrom only, right? Angstrom. So we can keep this value in angstrom for the simplicity of calculation. You are asked to find what is the radius of nth orbit. N is equal to 3 here, right? Third allowed orbit. N is equal to 3. We can calculate R3, radius of the third orbit, is equal to same R0 into 3 square, right? N square becomes 3 square. So R3 is equal to 0.53 into 9, right? And that is going to be 4.77 angstrom, option 3. See? Time-saving question, of course, like direct substitution, we know the value. Very simple. Yes, 37, option 3. Now, question number 38. Calculate the maximum acceleration of a moving car so that the body lying on the floor of a car remains stationary. Floor of the car remains stationary. Coefficient of static friction between the body and the floor is given as 0.15. Yes. And G is to be taken as 10 meter per second square. Right. The question from mechanics part again. See, we have a car moving in a particular direction, which is the front side. We'll take this as the front side. Fine. The car is moving in this direction and we have a body kept on the floor of this car. When the car moves in this direction, this body experiences a force in this direction, right? So there will be an acceleration of that particular body in this direction. Correct? Yes. Now, whenever the box experiences a force in that direction, there will be an opposing force. We know that is the frictional force. Frictional force will act in this direction. If M is mass of the block, what will be the force towards right? Force towards right, F is equal to M into A. And opposing force, which is the frictional force, right? We know frictional force. Frictional force is mu M into G for a horizontal floor. We'll come to that. And when these two forces are equal, that block remains stationary, right? Those two forces should cancel each other. Yes. So the condition for the block to be stationary is the frictional force should be equal to force acting on the body, MA. What is that A? Acceleration of the car. The question is, what should be this acceleration, right? What should be this acceleration? The maximum acceleration of the car allowed so that the block remains stationary. We have to find out this acceleration. Yes. How will you find out the static frictional force? Static frictional force is always on the horizontal surface. We know if the block is kept on the horizontal surface, frictional force will be mu S into R, right? Mu S into R. R is the normal reaction. For a horizontal floor here, weight and normal reactions are equal. So instead of R, you can even write mu S into mg. This is the frictional force. Yes, so we can substitute here. Frictional force is mu S into mg, which is equal to m into A. See how simply we solved it. We can cancel m on either side. You're asked to find this acceleration. Mu S into G is equal to the acceleration, required acceleration. You are given mu S value in the question, 0.15. So 0.15 and you are allowed to take G as 10. That is a required acceleration, which means 1.5 meter per second square should be the acceleration. And that is the option 2. Okay, equilibrium, right? That concept is, the question is based on the concept. Correct. Now, question number 38, option 2. 39. A question from electricity, current electricity, but that's a very simple question, I hope. 10 resistors, each of resistance R, are connected in series to a battery of EMF E and negligible internal resistance. Then those are connected in parallel to the same battery. Then the current increases N times. The value of N is. See, that complication of internal resistance is reduced. You are allowed to neglect the internal resistance of the cells, and we will connect 10 resistors in series, identical resistance. Each of resistance are connected in series first. So in series combination, what will be the current? I is equal to E divided by resistance of the combination, R equivalent. When you connect 10 resistors in series, we can say E divided by 10R will be the current in series combination, correct? In series combination, this is the expected current. Okay, what happens when we connect them in parallel? In parallel combination, again current I dash is going to be equal to E divided by resistance in parallel combination, equivalent resistance in the parallel combination, correct? Yes. What is equivalent resistance in the parallel combination? 10 resistors are connected, each of resistance R. Then it is R divided by 10, correct? R divided by 10. 10 comes up. I dash is going to be E divided by R into 10. Into 10. I can just rewrite I dash as E divided by 10R. Why? E divided by 10R, we have equation number 1 here. E divided by 10R into 100. That will give you the same result. Correct? E divided by 10R into 100 gives you the same result. We can say I dash, the new current is 100 times I. When you connect the cells in parallel combination, the current becomes N times, 100 times the current in the series combination. What was your question? Look at that. The current increased N times. When you change the series combination into parallel combination, current increases N times. So what is the value of your N? Value of N is 100, which is option 1. Correct? Question number 39. Option 1 is the correct answer. Yes. And question number 40. Yes. Again, a question from mechanics. Seems to be a horizontal bridge is built across a river. A student standing on the bridge throws a small ball vertically upwards with a velocity 4 meters per second. The ball strikes water surface after 4 seconds. The height of the bridge above the water surface. You are allowed to take G is equal to 10 meters per second square. Yeah. So the question, again, a very simple question we got. Suppose this is the bridge from which a student standing on the bridge. That is what question says. So this is the bridge. And the bridge is like a height at a height h from water. This is the water level, imagine. Then height is given as h. This is the h. This is to be calculated. How far or what is the height from the water level from the river to the bridge. Now, what is the motion given? A body is thrown vertically upward with a velocity, initial velocity 4 meters per second. It is thrown vertically up. Okay, it is found that this body vertically up, it was moving vertically upwards and it comes down to the water surface here. It misses the bridge and touch the water surface after how many seconds? After 4 seconds. So total time of journey is given as 4 seconds. Total time of journey is given as 4 seconds. Okay. The body is thrown vertically upward. U, initial velocity is 4 meters per second. That is also given. It is motion under gravity. We know motion under gravity. Acceleration will be acceleration due to gravity 10 meters per second square. And we have to assign the signs here. Look at this. If you take upward direction as positive, if your velocity, if you take initial velocity as positive, 4 meters per second as positive, all opposite direction should be taken as negative. So this should be negative. And we know direction of G is vertically downward. So your G value or your acceleration value should be negative. So A should be minus 10 meter per second square. Okay, right. Then in this case, we can say height, this h is the displacement of the motion. Like the body started its motion from A, it end the motion at B. So what is that h? H is nothing but displacement of this motion. Displacement of the motion. Yes. So you simply have to calculate what is the total displacement of the motion using equations of motion. We use S is equal to ut plus half at square. Yes. We have to find out that displacement. That is the final answer. That displacement is the height from the surface, right? Because body started from here, ends the journey on the water surface. So the total displacement is nothing but height of the bridge. So that S is equal to initial velocity 4 meter per second, 4 into time taken is 4 seconds minus, because our acceleration is going to be minus. That is why half into 10 into t square. T square is 4 square. So we have 16 minus 5 into 16, right? 5 into 16. So we get 16 minus 5 into 16 is going to be 80. Got it? Yes. So that is minus 64 meters. Look at the sign of the displacement. Sign of the displacement is negative, right? Why? Because if upward direction is positive, your downward direction should be negative. Not only G, your displacement is also vertically downwards. So that should be negative. Minus 64 meter. And that is option 2. Yes, you have just the magnitude of the displacement. Height is to be found out, 64 meters. Okay.
Brilliant Qatar, your trusted coaching partner for IIT, JEE, Neet, Science and Commerce tuitions with 10 years of excellence in quality training. Brilliant Qatar.